is finding limits using graphs and tables. So those of you that had pre-calc last year, you might have had a little preview of this. If you guys had summer pre-calc, you have not seen this before. So if you get confused, ask questions. But yeah, we're just going to kind of start from the beginning as if you haven't seen it at all. Okay, so in basic terms, a limit is the y value that you get closer and closer to as you move towards a certain x value from both the right and the left. Okay, so imagine you're tracing along a curve from the right and the left. So maybe I'm tracing along this curve, and I'm getting closer and closer to an x value of 0, right? X equals 0 is here, from both the right and the left. What y value do I get closer and closer to when I do that? 2. Now, is the point filled in at 2? No. Okay, so a limit does not have to be filled in at all. It could be an open circle, but we're saying as I plug in like 0.5, 0.1, 0.01, 0.001, and I get closer and closer to 0, I'm getting closer and closer to that value. All right, now if you have something like this, and I get closer and closer to an x value of 1, as I go from the right and the left, the right side goes to a y value of 0, the left side goes to a y value of -1. If they do not go to the same thing, then the limit does not exist as x goes to 1. Does that make sense? You guys talked about Mean Girls the other day. Do you guys remember the Mean Girls example? Yeah, so in her little math club, she has 1 over x, and they say, well, what is the limit as x goes to 0 of 1 over x? And let's think about it. As I approach from using my right hand and getting closer to x equals 0, what y value do I get closer to? Yeah? Infinity. But as I take my left hand and I get closer and closer to 0, what y value do I get closer to?
Negative.
So do they go to the same thing? No. So that's why the limit does not exist. Does that make sense? Didn't she think really, really hard about that question? It seems like it's going to be a really, really hard question in the movie, doesn't it? But it's not. It just does not exist. All right, so number 1 says, suppose we have the function f of x equals x squared minus 4 over x minus 2. So we know that if we plug in 2 right now, so if I plug in 2 for x, I get 4 minus 4 over 2 minus 2. So I get 0 over 0. So f of 2 is undefined. There's not actually a point at 2. But there could be a limit. So as I plug in values that get closer and closer to 2, I get different things. So I went ahead and I plugged that in for my y1. So I put x squared minus 4 over x minus 2. And if I go to my table and I plug in different values like 1, 1.5, 1.9, 1.99, notice how my values are getting closer and closer to 2. What happens to my y values as I plug in 1.99999? It actually gave me 4, but it shouldn't. Right? It's giving me 3.99999. Does that make sense? So the pattern is that each time it's 2 more than what we had. So as I plug in 1, I got 3. As I plugged in 1.5, I got 3.5, 3.9, 3.99, 3.999. So as my limit goes to 2, it looks like from the left side, because we're plugging in 1, 1.5, 1.9, 1.99, as I'm approaching from the left side, I'm getting closer and closer to what y value? 4. Did you guys see that? Now, does the same thing happen for this side? Sure. This one gave us 5. This one gave us 4.5, 4.1, 4.01, 4.001. It's also going to 4. So if both my limits from the right and the left go to 4, then I can say my limit as x goes to 2 is 4. So why is that? Well, we learned how to graph something that looked like this in Algebra 2. If you guys remember, it factors. It factors into x plus 2 times x minus 2 all over x minus 2. And we can cancel the x minus 2's. So really we have a line. So we have the line y equals x plus 2 with a hole at x equals -2. Not -2, at x equals 2. Okay, so it looks like a line. It looks like that. So as we approach from both the left and the right, they both went to this y equals 4 value, but there's no point there. That's okay, the limit is still 4. So why does it look like a line? Because when you factor, you have a hole, right? And the simplified version is a line. All right, so sometimes it won't always be that easy. Okay, so this one's a little bit different. This is a piecewise function. We have g of x equals x minus 1 over x squared minus 1 if x is not equal to 1. Well, what does that look like? Let's see. X minus 1 over x squared minus 1 is x plus 1 times x minus 1. This does not factor, it does not like reduce down to a line. It reduces down to 1 over x plus 1. Okay, and this is a hyperbola. It looks like 1 over x, only it's been shifted. Think about our math aerobics. Where has it been shifted? Left 1, right? Do you guys see it? Left 1. Why is that? The vertical asymptote is at negative 1, right? So it's right here. But otherwise, it looks just like 1 over x. When we were just talking about, that was on Mean Girls. So we have that. So this is saying we typically look like this graph, except, so we're going to look like that everywhere except at x equals 1. So at x equals 1, I'm going to have a hole. My drawing is terrible. Can you guys see I have a little hole there? Maybe I should zoom in. A hole. I don't know if it's actually at 1. We'll draw it like right around there. Oh, I still forgot my asymptote, didn't I? I'm really having trouble drawing this. So it's looking something like that. All right, but we're saying, well, at 1, we have a hole, except we also have the point 1, 2. Do you guys see how it says it's equal to 2 if x is equal to 1? So we're up here. So we have an open circle and we have a filled in circle. So we want to know what the limit is. Anybody have any guesses? It's some number. What number is it? 1/2. Syra, how did you get that? You were correct.
So I just put 1 in the first 1 over x plus 1.
Yeah, so if you use the simplified version, right, and you plug in 1, then we can get 1 over 2. And that's what the limit is. It's saying, where would that hole be once I get rid of the whole part, once I reduce it out? It would be at 1/2. So that point right there is 1, 1/2. The one that was open. So that's why our limit is equal to 1/2. Does that make sense to everybody? Can you get it? All right. So it says in order for the limit as x approaches a to exist, it needs to go to the same y value from both the left and the right. So we need a certain way of notating this. We need to be able to talk about right-hand and left-hand limits. So on the left side of a graph, we have negative numbers. On the right side of the graph, we have positive numbers. So if we talk about the left, we write it as the limit as x goes to a, and we do a little exponent. That's a negative. Looks like a little exponent. It's just kind of a superscript, right? So we need for that to equal that limit, like a certain L value. And we need for the limit as x goes to a from the right, so do an exponent that's a plus, of f of x to equal L as well. So if they both, say the limit from the left and the limit from the right are both equal to 6, then you can say the limit as x goes to that a value in general is 6 as well. Okay, so let's do some pictures. And this is what your homework looks like. It just has a whole bunch of pictures like this. All right, so it says for the function graph below, identify each limit or state that it does not exist. So we're saying 0 from the left. That's how we read that. So the limit as x goes to 0 from the left of our function. So I'm going to take my left hand. Everybody raise their left hand. And you're going to take your left hand and you're going to get closer to the x value we're talking about. So here's the x value we're talking about. We're getting closer to this line from the left side. So as I get closer to the line from the left side, what y value does it get closer to? 3. So the next one, limit as x goes to 0 from the right-hand side. So as I take my right hand and I get closer and closer. Yeah, it goes to 1. So the limit as x goes to 0 in general, were they the same thing?
No.
Nope. So we write does not exist, D and E. Okay, limit as x goes to 5 from the left. Do not read that as negative 5. Everybody just kind of, their brain twists it around into negative 5. It's 5 from the left. So 1, 2, 3, 4, 5. Here's 5. So what y value?
3.
3, yeah. So we're getting closer and closer to 3. -2. We're getting closer, so right and left this time, right? We didn't say right or left, so we use both. We get closer and closer to the y value of 3. How about the next one? So 1 from the left. Be careful, 1 is over here, right? It is not -1. So 1 from the left, it gets closer to 2, is that what you said? Yep, 2. 1 from the right, it also gets closer to 2. So if I just talked about the limit as x goes to 1 in general, it would be 2. All right. Oh, I did ask that, didn't I? And the limit as x goes to -3? 1, yep. So then the question says, well, what is f of 1? What is the filled in point at x equals 1? What's the y value of the filled in point? It's right here, right? That's the f of 1. It's equal to 1, 2, 3, 4, 5, 6. F of 1 is equal to 6. So why is it different? A limit does not have to be a filled in point, right? So the limit is the y value that you get closer to as you plug in like 1.1, 1.01, 1.00001, right? Or 0.9, 0.99, 0.99999, right? So it's very different. Okay. You guys want to try one on your own? Try it. So don't look up here. I'm going to write the answers as you guys were doing this. And then check at the end. All right, so check the answers you have so far. So 2a, did you get 3? So limit as x goes to -3 from the right. Yep, 3. B, limit as x goes to -3 from the left. So you're getting closer to -3 from the left, and you're getting closer to that y value of 6. So -3 in general is D and E, because it's not the same from the left and the right. D, as you approach 4 from the right, you get closer and closer to -4. As you approach 4 from the left, you get closer and closer to -4. So 4 in general would be -4. All right, limit as x goes to -6 from the right. As you get closer to from the right side, you get closer to 3. Do you guys have all these values? All right, -11, that was this one here. And that's -4. Infinity, notice how it's going off forever in the positive direction. So as x gets really big, y gets really big. It's kind of like end behavior when you talked about that in Algebra 2. As x goes to infinity, y goes to infinity. All right, limit as x goes to -infinity is -infinity. Limit as x goes to -6 is D and E, because they did not go to the same value. So this one went here, this one went here. And then this last one is asking a question in kind of a strange way. So it's saying, if the limit as x goes to a of f of x equals 0, what are two possible solutions for a? So let's think about this in, regular words. So we're saying, as x gets closer to a certain number, the y value is equal to 0. So as x goes to a certain number from the right and left, what y value, how do I get y value of 0? So I have a y value of 0 here and here. So where does that occur? At a equals 0 and a equals 8. Those are the x values, right? That's what we're saying. Does that make sense? These U days confuse me. I think I still have a couple minutes. All right, do you guys want to try this one really quickly, or do you want me to do it for you? So for the function graph below, identify each limit or state that it does not exist. So as you approach -3 from the right, so here's 1, 2, 3, -3 from the right, you go to 1, 2, 3, 4, 5. So that one's 5. Negative 3 from the left goes to 1, 2, 3, 4, 5, 6, 7. Negative 7. So negative 3 in general is D and E. 3 is going to be 1, 2, 3, 4, 5. As you go towards 0, what y value? Negative 4, perfect. 11 from the right, this is probably 11, I'm guessing. 1, 2, 3, 4, 5, 6, 7, 8, is it 9? Negative 6. Negative 4. Negative infinity, what do we think for negative infinity? Yeah, it's a horizontal asymptote, right? Negative 4. Kind of like it just goes straight out forever like that. It's not really an asymptote, I guess, but a horizontal line. And infinity? 9. Do you guys understand this section? All right,
It's hard
good.
counting a square.